Well, hello and welcome back to my one-car garage machine shop where I want good results. And if you're looking for good results with older equipment, you gotta make it happen. Now, I've talked a lot about these old chucks that I've picked up, and particularly this one here for right now. This is a 12-inch Bison forged steel chuck, and if you look at Penn Tool Company, this retails for $3,600, and I've seen these locally for about $200 to $300 on Craigslist. A 12-inch, actually I think 12 and a half, and the specs on this thing for radial runout is 2 thousandths, and they said axial runout is 1.5 thousandths. And this came on this machine, and on some of my earlier videos I pointed out on early machines like this is a 1941 Axelson lathe, that they didn't grind the spindle tapers in place. So the runout maximum that I found in a Dean Smith and Grace manual, a similar machine but made in England, was up to 1/2 thousandths runout on the spindle nose, both the taper and the face, and this is within that. And so when this chuck did come on this machine, I bought this machine. It was the least expensive machine on eBay at the time, and this was sold by Yoder Machinery in Ohio, and a lot of people around here use that company, and it's a good company as far as my experience goes. And like a lot of machine tool dealers, this is was discounted down to $3,200 at the time, and I grabbed it, and what a good deal. It had this chuck on it, and what I had to do to make this chuck work this well, I'll demonstrate that in a minute, is machine the back plate to fit the spindle taper tighter, so it didn't slop around. And this is a plain back chuck with a back plate that the chuck bolts to. So of course I machined the back of it so it fits the spindle tight. Then with it on the spindle, I machined the face of it, which is very common to do, then mounted the chuck to it. So after doing that, I checked the body of the chuck here. Let's see if I can get this over there good. I got an old inner rapid on here. So the body runs out here 1.5 thousandths on that old inner rapid, and their radial runout spec is 2 thousandths for something in the spindle. So I got the body running well within that. It has a snug fit on the shoulder and everything, and that's where it ended up, because, you know, of course you machine the interface on your back plate. So it ended up in a good spot, runs within 2 thousandths and a half on both the face and the perimeter of it, which this is the radial runout, and the face will be the axial runout. All right, I'll try not to get too confused. I'll get that out of there for now. Now let's see, I'll set it over here so I don't knock it down. Okay, so I got this piece of steel mounted in here, and a good way to check axial runout is on a length like this. And you can see I got this indicator here in a good spot. Let's see what it is. Runout on that end is about a 0.5 at most. And we'll check it up closer to the jaws here. It will be more of the radial runout. You can get a good idea on the other end of the axial runout. See, we're well within its range here. Let's see what it is. Always bumps over a little bit. I'll move it a little closer. There we go. Hitting the nick or something there. A little bit closer, see if I can get off the jaw nicks. Let's see, get that. So right on top of it pretty much. Got a good scratch in it that it's bumping off of. But that's well within a 0.5 also. So I beat the expected runout on a new chuck, and this is not a new chuck. I reground the jaws. So it's 4 times better than a new chuck maximum runout. And I like that. Okay, let's try some different sizes here. And we'll get it up here. Get that piece out. And we'll put something a little smaller in, and we'll go a couple rounds with that. Here's a piece of very hard steel that I was cutting on. We'll wind this thing in there and see where it is. Getting close there. Okay, now when I put something in a chuck, I like to turn it slightly. Bring the jaws just so they touch and you get a little friction, and find a smooth spot and snug her down. Okay. No, that's not on my master pinion. I'll try it again here. Now, it'll always be more consistent on using the same pinion that you ground the jaws. Used to put the preload on. Feels right good. Real good right there. Snug it. And we'll see what it is. And get it back here. Better than 0.5. It's almost dead on. Okay, let's go with a size smaller. Here's something smaller. This piece of ground steel here. Now I'm going to do the same thing. I got it on the master pinion. I got that marked with some X's. And I just bring it just so it touches and I can still rotate it. And you find a smooth spot, then you know you're not on a burr. Give it a good snug there. And we'll put that on there and see where we're at. Sometimes if it's not running true, you might have to do it another time or two. But let's see how we're doing here. Now I see people grinding jaws, but they don't show the results like this, because I don't think they're getting these results. Okay, again, better than half thousandths. You see this? That indicator works perfectly fine. Okay, let's try a size smaller. Get it on the master pinion here. Sometimes it's good to use the other pinions for loosening and save the master pinion for tightening. And what have I got here? Okay, here's something very small. This is an ejection pin for plastic molds, and they're accurately ground. 3/8 of an inch on that. So we go from almost 3 inches to 3/8 of an inch. And let's see how this runs 3/8 of an inch, okay? Got it in there. And I'm rotating it ever so slightly. It feels like very smooth, and I'm going to snug it right there. Okay. And let's get that indicator on there. Sometimes the smaller diameter is just a little bit tricky. I'm not sure how small this particular chuck here will run. Well, look at that. Now, I'm not joking. It's working. See, I'll jiggle it. It's within a half thousandths, easy. Okay. Now, how I do this? How do I get these results? I've watched other people do this. And they go, oh, it's a thousandth or so, and that's good enough. But they only do it on one diameter. Now, okay, let's get this over right here. Make sure I got everything tight and nothing falls loose here. Okay, this is an 8-inch Cushman here that I've ground, and I've demonstrated this is the same. It's just very, very good, very, very tight. So this is the loading rig here. Very simple. You got a large ring with 3 rings in the middle. Let's look at it. You can see how I machine these and split them. Now, it doesn't have to look this good. I made this one look pretty nice. And I was able to use this on both these 3-jaw chucks. So when you tighten this thing, I think I demonstrated this in the last video a bit. So you're going in the direction of tightness here. And it's just let me get it just barely tight. You know, just start snugging it. And it starts moving less and less. And you see, it's even. These all feel even. That's what 3 points do like that. And this is much better than sticking elongated bolts out and grabbing a ring or something. This just works really, really well. You can load it and grind the jaw. See, I got the clearance there. Okay. Now I'm going to flip the chuck over here, set this over here. Set that down. Flip this thing over. Now, the way I've machined the backs of this, and I did a video here on the DD channel doing this on this horizontal milling machine here, using the wall hopter to face this out, and then use the tree boring head to do the angle here, the nose angle. And of course, this can be done on the lathe, but since I have those specialty heads, it's really easy to plop this thing down on a table, then mount it on a faceplate or a four-jaw chuck. But that's how I did it before I had those heads, with the same results. So this particular chuck here, and along with that Bison there, was loose on the taper. And there's some variations in the tapers on these lathes. Like the taper on this lathe just happens to be a little bit smaller than usual. And so most of the time chucks you can take the pins out and stick it on there, and you could slop it. The taper here didn't grab very good. So you machine it at the point where this taper grabs. But this taper can be too tight, and I ran into that on that lever collet closer that I fit on this machine. So they can be too tight or they can be too loose, but usually I run into them and they're a little bit too loose. Now on this machine here, the Axelson, there's a little bit of runout on the spindle that there is not on the Monarch 10EE. So the 10EE is so accurate, it doesn't matter where the chuck is. But with a little bit of runout on some of these engine lathes, you gotta mark the chuck so it goes on the same place. And I have a little mark right here that goes to the number 1 pinion on the lathe. Okay, so this is how I accomplish what I just showed you, which makes me very, very happy. Okay. Well, we've had some real good weather, and I've been spending as much time outside as possible. And I've got these machines here really in good shape. I'll take this loose. The only real modification I did in here was I put a board over that window because it goes into the neighbor's backyard. And I don't need to see what he's doing, and you don't need to see what I'm doing. So I covered that window with a piece of 1/2-inch hardwood plywood, and then made those racks with pegs to put my grinding wheels there in a very convenient and nicely laid out space. So my last project that I got to do, and it will be my next video, is I'm going to finish the radial drill press. Okay, you guys have a good day, and I'll get another video going real soon on the last of the little things I have to do on that drill press. Then I got a lot of tooling to make for it too. And that's going to be an incredible addition to my little shop here and add huge capability. Okay, have a good day.